Hello! In this video today, I'm going to talk about a very common misconception, and that has to do with Newton's third law. It's one of the most widely misunderstood concept. So, what do we say? Say that the book exerts a force on the table exerts an equal and opposite force on the book. That's Newton's third law? No, it's definitely not Newton's third law. It can be if we think of it in a way, but there is more to it. For Newton's third law to be meant, there are three conditions which must be satisfied. There has to be a pair of forces which are equal and opposite, right? Forces must be applied on two different objects. In this case, it's a book and the table. And third point is the forces must be of the same nature. Forces must be of the same type. And that's a very important point to know, and that is what we normally ignore. Let me explain. Book and table both are passive objects. A book cannot exert a force of its own. It's the force of gravity which pulls down the book, of course, right? A book itself does not have or is not capable of exerting any force. If this was in a zero gravity situation, the book would not be exerting any force on it. So it's the force of gravity which pulls it downwards. So it's the weight of the book which comes from gravity. But then, how come table exerts an upward force? There is no such thing as anti-gravity, right? Table is a passive object as well. Table cannot exert any force in an opposite direction, just like a book itself cannot do that. It is the force of gravity which pulls it downwards. So how come table exerts an equal and opposite force? What is pulling the book upwards? Weight, or the gravity is pulling the book downwards, but where does the upward force come from? And the answer lies in the merger of physics and chemistry. So if we think that, what is this book made up of? Atoms. What is the table made up of? Atoms. What do atoms have around them? Electrons. And electrons are negatively charged. So electrons of the book repel the electrons of the table. So that is where the upward force, which we normally call as normal reaction, it comes from, because electrons repel other electrons. And if we think of it like that, then no two objects actually ever touch each other. So if I do it like this, if my fingers, they're not actually touching if we really look at the atomic scale, because the electrons of these two fingers will actually be repelling each other. And we used a similar concept, and we built something very fascinating which is called atomic force microscopy and AFM. I would not explain about AFM in this video, but I would really encourage if you can see what wonders we can achieve. One of my absolute favorite tools that I've ever used in my engineering. Yeah, AFM. You can literally do atomic manipulation. You can move atoms just by this force of repulsion of electrons of one atom and another atom, and you can build up an object atom by atom with the help of these. Anyways, coming back to Newton's third law. So yeah, if you describe the same situation, that book exerts a contact force downwards on the table, and the table exerts a contact force upwards on the book, which is equal and opposite, and now the forces are of the same type. This can be described as Newton's third law now. But if you say the book exerts weight downwards on the table and the table exerts a normal reaction upwards on the book, then it would not be Newton's third law. So for two objects to satisfy Newton's third law situation, the forces must be equal and opposite. Forces must be applied on the two opposite objects, and forces must be of the same type.